Good morning, students. Exercise 8.2, the problem number 7. Show that the vectors 2i cap minus j cap plus k cap, 3i cap minus 4j cap minus 4k cap, I cap minus 3j cap minus 5k cap form a right angle triangle. So see, here it is given, show that the vectors. So vectors are given. So we have to show the three vectors form a right angle triangle. So I have considered the right angle triangle ABC. So here the vectors are given. So they represent the sides of the triangle. So we can take the first vector as A vector, the second vector as B vector, and the third vector as C vector. A vector, B vector, C vector, they are nothing but the sides of the triangle. Okay, so we have to prove that they form a right angle triangle. So for the right angle triangle, if you verify Pythagoras theorem, we can say Pythagoras theorem is verified. So we can say the triangle is a right angle triangle. So for that, we need the length of the side. Okay, so the first vector A vector is represented by the side AB vector, means we have to find the length of the side for verifying Pythagoras theorem. So the length of the line segment is nothing but the magnitude of the vector. So to find the length of each side of the triangle, we have to find the magnitude of these three vectors. So first you have to go for magnitude of A vector, that is modulus of A vector. How to find the magnitude in terms of x, y components, x, y and z components? It is nothing but square root of x squared plus y squared plus z squared, that is 2 the whole square, plus the coefficient of j cap is minus 1 the whole square, plus the coefficient of k cap is 1, so it is 1 square. So that is square root of 2 squared is 4 plus 1 plus 1, that is equal to root 6. In the same way, take the second vector and find the magnitude. So it is nothing but square root of the coefficient. What is the coefficient? 3. So 3 the whole squared plus minus 4 the whole squared plus minus 4 the whole squared. So that is equal to square root of 9 plus 16 plus 16, that is equal to square root of 41. And you have to go for modulus of C vector. So modulus of C vector is square root of, here 1 the whole square plus minus 3 the whole square plus minus 5 the whole square. So that is equal to square root of 1 plus 9 plus 25. So the answer is square root of 35. You consider modulus of A vector the whole square plus modulus of C vector the whole square. Modulus of A vector is what? Root 6. Root 6 the whole square is 6. Root 5 the whole square is 35. If you add these two, it is 41. 41 can be written as square root of 41 the whole square. What is square root of 41? That is modulus of B. So modulus of B, the B vector, the whole square. You see now why I have found the square? According to the Pythagoras theorem, the hypotenuse, the square of the hypotenuse is equal to sum of the squares of the other two sides. For that only the square of each vector is, that is the square of each vector is found. So we have proved the Pythagoras theorem. So therefore the given vectors form the right angle triangle. So this word is important. Vectors are given means you can take A vector, B vector, C vector. They are nothing but the sides of the triangle. If the points are given means you have to take the position vector. Okay, you see the next one. 11th problem. A vector, B vector and C vector are given. Three vectors are given. Find the magnitude and direction cosines of first subdivision A vector plus B vector plus C vector. In the second subdivision 3A vector minus 2B vector plus 5C vector. Okay, so first subdivision you consider. Here first which vector is needed? A vector plus B vector plus C vector. The three vectors has to be added. The addition, you have to find the magnitude and direction cosines of the addition of three vectors. So first we have to find the A vector plus B vector plus C vector. So each one having the x, y and z components. So it has to be added. Okay, you see that a vector, the what is that, x component is 2 I cap. Here the x component is 3 I cap. Here you are having minus 3 I cap. So if you add plus 3 I cap and minus 3 I cap getting cancelled, you will have only 2 I cap. So 2 I cap. In the same way, j cap, all the j cap has to be added. So it is 3 j cap minus 4 j cap. So when you add these two, it is minus j cap. Minus j cap plus 2 j cap is, what is it, j cap. And you add the components of z components. Minus 4k cap minus 5k cap, that is minus 9k cap. Minus 9k cap plus 3k cap is minus 6k cap. Okay, so I have added the three vectors. Then you have to find the magnitude. So what is asked? Magnitude and direction cosine. So first we are going to find the magnitude. How to find the magnitude? It is nothing but modulus of a vector plus b vector plus c vector. That is equal to square root of, you see, 2 the whole square plus 1 the whole square plus minus 6 the whole square. That is 4 plus 1 plus 36. That is equal to square root of 41. Next, for this vector, you have to find the direction cosine. So the formula is what? X by r, comma y by r and z by r. What is r? R is nothing but square root of x squared plus y squared plus z squared. That is the magnitude of this vector. Okay, so already we have found the magnitude of this vector is root 41. So the direction cosines of this vector is x. What is x? 2. 2 by r. What is r? The magnitude, that is square root of 41. And what is y? It is 1. 1 divided by square root of 41. And z minus 6 divided by square root of 41. See the second subdivision. What is here? 3a vector minus 2b vector plus 5c vector. First we have to find that. Okay. So first 3a vector. What is 3a vector means? It's a scalar multiplication of vector. That means a vector has to be multiplied with 3. So all the components has to be multiplied with 3. 3 2s are 6 I cap plus 3 3s are 9 j cap minus 12 k cap. So here you will have 6 I cap plus 9 j cap minus 12 k cap. And next one, here what is asked? Minus 2 b cap. So I am going to find minus 2 b cap itself. So b vector has to be multiplied with minus 2. So it is minus 2 into 3, that is minus 6 I cap. Minus 2 into minus 4, so plus 8 j cap. Minus 2 into minus 2, that is plus 10 k cap. I have written minus 2 b cap itself. Next one, what is asked? 5 c cap. So the c vector has to be multiplied with the scalar 5. So it is minus 15 I cap. Here it is plus 6 j cap. Okay, sorry. Here 5, if you multiply with 5, it is 10 j cap plus 15 k cap. So I have found all the three results separately. Here I am going to add all the three because already I have found minus 2 b cap. So I am going to add all the results. So how to add? You have to add the x component, that is I component has to be added. So 6 I cap minus 6 I cap getting cancelled. So you will have only minus 15 I cap. The same way 9 plus 8. So 9 plus 8, what is it? It is 17. 17 plus 10 is 27 j cap. And minus 12 plus 10 minus 2 k cap. Minus 2 k cap plus 15 k cap is 13 k cap. And what is asked? Magnitude of this. So magnitude means modulus of this vector. How to find the modulus? It's a square root of minus 15 the whole square plus 27 the whole square plus 13 the whole square. So if you find out, you will get the answer as square root of 1123. Okay, so the next one, what is asked? Direction cosine. So you are going to use this formula. So here r is nothing but what? Modulus of this vector. So already we have found. So what is your x? So minus 15 by square root of this 27 divided by square root of 1123 comma 13 divided by square root of 1123. Okay, so we'll see the 12th problem. The position vectors of the vertices of the triangle are. You see the word, the position vectors of the vertices. So if we have triangle, if we have the triangle, so what are the vertices? A, B, C. So now here what is given? The points. The points or the position vector. About this point is A means what is the position vector of this? OA vector. So OA vector, OB vector, OC vector are given. Okay. Find the perimeter of the triangle. So perimeter means what you have to do? You have to add all the sides. You have to add all the sides. That is the perimeter of the triangle. So what is needed now? You needed AB. Next BC. Next CA. Okay, first we should know the side. We do here only the position vector of this point is given. Position vector of the point is given. So using that you have to find the side AB. So first we are going to find AB vector. So here what you are having, position vectors are there. So using position vector, how you can write AB vector? Position vector of the second point minus position vector of the first point. Okay, so that is AB vector is equal to OB vector minus OA vector. So see that OB vector. You see the subtraction here. I cap, J cap, K cap. Components you have to write. So that is the coefficient you have to write. First which vector is there? OB vector. So that coefficient you just write. What is it? 3. What is it? Minus 4 and 5. Write in the rough work. Okay. So next minus OA vector. So OA vector in the same order you just write the coefficient of I, J, K of OA vector. What has to come? It is 1. At the next one, 2. Next one, 3. Okay. In between what you are having? Subtraction. So minus. So you have to change the sign. So it is minus. Here you are having minus. Here you are having minus. You just do the calculation. 3 minus 1 is 2. Here minus 4 minus 6 is minus 6. And here you are having 5 minus 3 is 2. Just I have found the coefficient. So you have to write as a vector 2i cap minus 6j cap plus 2k cap. So a shortcut if you use, you will not commit mistake. So next one, AB side we have found, that is AB vector we have found. So the triangle has 3 sides. The other 3 sides are BC vector and CA vector you can find. You can go for AC vector also. Whichever you want you can find. So BC vector, how you have to write using position vector? OC vector minus OB vector. So in the rough work, you have to write the coefficients of I cap, J cap, K cap of OC vector first. What has to come? It is minus 2 and 3 and minus 7. I have written that. Next OB vector. What is the coefficient of OB vector? It is 3. What is it? Minus 4 and 5. So in between what you are having? In between you are having the subtraction. So you have to change your sign. Minus, here you will have plus, here you will have minus. So therefore minus 2 minus 3 is minus 5, 3 plus 4 is 7 and minus 7 minus 5 is minus 12. So we have found the coefficients. Here you have to write as a vector. So minus 5 I cap plus 7 j cap minus 12 k cap. In this way you can find. So next one, you can go for the third side. CA vector you can write, otherwise AC vector. Anything you can find. So here I have found CA vector. So using position vector, how it will be written? OA vector minus OC vector. So see the subtraction. First vector is what? OA vector. Take the coefficient. So 1, 2, 3. And next vector is what? OC vector. Take the coefficient of minus 2, 3, minus 7. And you have to change the sign. So it is plus. Here you will have minus. Here you will have plus. What is 1 plus 2? That is 3 I cap. 2 minus 3 is minus j cap. 7 plus 3 is 10 k cap. So now what you have completed? You have the position vector of this point. Just you have found AB vector, BC vector and CA vector. You have completed the sides. Okay. You have found the sides. So perimeter means you should know the length. Okay. So length of AB. you have to find. So length of AB means you have to find the magnitude of AB vector. So AB vector is here, whose magnitude, that is magnitude of AB vector is nothing but the length of the side AB. Okay, so that is square root of AB vector is here. So you know that how to find the magnitude. Square root of x squared plus y squared plus z squared. So x is the coefficient of I cap. So that is 2 squared plus minus 6 the whole squared plus 2 squared, that is equal to square root of 44. In the same way, you have to find the magnitude of second side, that is modulus of BC vector. Next, you have to find modulus of CA vector. So root 44, root 218, and the third side the magnitude is square root of 110. So the perimeter of the triangle, if you add all the results, that is the perimeter of the triangle. Come to the 17th. Show that the points are vertices of an isosceles triangle. See here what is given? The points. Points are given. So if we have triangle, so the points, what is it? A, B, C. They are the vertices of the isosceles triangle. So here the points are given. So using the points, if one point coordinate is there, that can be taken as OA vector. What is OA vector? I cap plus j cap plus k cap. In resolution of vector in 3 dimension, we have learned that only. So B vector is there. So B point is there. So you can find OB vector as I cap plus 2j cap plus 3k cap, and C point is there, so you can find OC vector, that is 2I cap minus j cap plus k cap. We have to form the vertices of an isosceles triangle. How the isosceles triangle? So what is it? The base angles are equal and the two sides are equal. Yes or no? So first we have to find the sides. So AB vector has to be written. How to find AB vector? Using position vector, OB vector minus OA vector. So here OB vector. What is the coefficient of OB vector? 1, 2, 3. What is the coefficient of OA vector? That is 1, 1, 1. In between what you are having? Subtraction. So you have to change the sign of the second vector. So minus, minus. So when you add these two, it is 0, 1, 2. So the answer is j cap minus j cap, and here you will have plus 2k cap. You see that? 3 vector minus. So here you will have plus 2k cap. AB vector is j cap plus 2k cap. And go for BC vector. How to find OC vector minus OB vector? So first you have to write the coefficient of OC vector, that is 2 minus 1, 1. So here OB vector, so the coefficient of OB vector is 1, 2, 3. Okay, and you have to subtract, in between minus sign is there, so you have to change the sign of OB vector. Okay, so it will be 2 minus 1 is 1. Here you will have minus 3. Here you will have minus 2. Just the coefficient is written here. So you have to write as a vector. So it is I cap minus 3j cap minus 2k cap. And you see in the same way you have to go for the next side. What is CA vector? So CA vector can be written as OA vector minus OC vector. See that OA vector, the coefficient is 1, 1, 1. And next one, what is it? OC vector. So the coefficient of OC vector is 2 minus 1, 1. And you have to change the sign of the second vector. So minus, plus, minus. So what is 1 minus 2 is minus 1. 1 plus 1. 1 minus 2 is minus 1. 1 plus 1 is 2. And 1 minus 1 is 0. So you have to write as a vector. So minus I cap plus, what is it? 2j cap. So we have found the 3 sides. So now we have to prove it is a isosceles triangle. So for that we need length. So length means it's a magnitude of AB vector, BC vector and CA vector. So modulus of AB vector, modulus of BC vector and modulus of CA vector. Using the formula square root of x squared plus y squared plus z squared. Using that you will get root 5, root 14 and root 5. So the modulus of AB vector is equal to modulus of CA vector, that is equal to root 5. So therefore the given vertices or given points, they are nothing but the vertices of an isosceles triangle. Okay, so next we are moving to see the parallel or collinear vectors. Already we have learned any two vectors are parallel or collinear. We can write one vector as a scalar multiple of other vector. See, if you want to say A vector and B vector are parallel or collinear vectors, we can write A vector is equal to lambda into B vector for some lambda. Lambda is a scalar. Okay, so exercise 8.2, eighth problem. Find the value of lambda for which the vectors are parallel. So here you have to find the value of lambda given the two vectors are parallel. So I am going to take A vector and B vector are parallel. So it is given that. So for that only I have taken. Given that A vector and B vector are parallel. So A vector and B vector are parallel. How you can write? One vector is a scalar multiple of other vector. So here A vector is equal to, here I have used lambda. In this problem also you are having lambda here. So that's why I have changed the scalar as m. So A vector is equal to m into B vector. So A vector is written in the left side, m into B vector is written here. Now equating the coefficient of I cap, j cap and k cap. So go for, here I cap coefficient in the left side is 3. Come to the right side, m into I cap. So m I cap. So the coefficient is what? M. So 3 is equal to m. What is asked? Find the value of lambda, not m. So we have to find, we equate the coefficient of j cap. So here you are having 2. Here m into lambda. Okay, so 2 is equal to lambda m. If you multiply j cap, lambda m j cap. So lambda m is the coefficient. So on that you have to substitute m as 3. So it is 2 by 3 is equal to lambda. So we have found the value of lambda if any two vectors are parallel. Okay, come to the 15th one. The position vectors of the point. This word is very, very important. Position vector of the points P, Q, R, S are given respectively. You see that the four vectors, they are the position vectors of the point P, Q, R, S. How to write the position vector of P? That is OP vector. So the first vector is OP vector. The second point is Q. So the second vector is OQ vector. And the third vector is OR vector. And the fourth vector is OS vector. What you have to prove? Prove that the line PQ and RS are parallel. So we have to show the two lines PQ and RS are parallel. So I am going to find PQ vector. So on that line I am going to find PQ vector. PQ vector, how you can write using position vector? OQ vector minus OP vector. You see that? OQ. What is the coefficient of OQ? 2, 5 and the K cab is not present, so I have taken as 0. And here OP vector. What is the coefficient of OP vector? 1, 1, 1. So in between what you are having? Subtraction. So you have to change the sign. Minus, minus, minus. So if you calculate, it is 2 minus 1 is 1, 5 minus 1 is 4 and 0 minus 1 is minus 1. So I have written only the coefficient. So you have to write as a vector. So PQ vector I have found. Next, which vector is needed? RS vector. So RS vector can be written as OS vector minus OR vector. So OS, what is the coefficient? It is 1, minus 6 and minus 1. I have written. OR, so it is 3, 2, minus 3. Okay, and here in between subtraction, so you have to change the sign of the second vector. So this will become plus. So what is 1 minus 3? That is minus 2. Minus 6 minus 2 is minus 8. And minus 1 plus 3 is 2. So here I have written minus 2i cap, minus 8j cap, plus 2k cap. So PQ vector and RS vector we have found. Okay, you look at this. So here you will have only I cap. Okay, so from this, if you take minus 2 out, it will become I cap. From this term, minus 2 is taken out, remaining is plus 4j cap. Here minus 2 is taken means it is minus k cap. What is this? I cap plus 4j cap minus k cap. This is your PQ vector. So RS vector is equal to some scalar. What is a scalar here? Minus 2 into PQ vector. So one vector is equal to the scalar multiple of other vector. So therefore they are parallel. Okay, on these two vectors, if we have common point, they are collinear. So parallel or collinear means we can write one vector is a scalar multiple of other vector. If they have common point, they are lie in the same line, so therefore they are collinear. If they don't have common point, they are parallel. So here there is no common point. What is common point? R, S, P, Q. The four are different points. They are not here common. So therefore they are parallel. And come to the problem number 14. The position vectors A vector, B vector, C vector of 3 points satisfies the relation 2A vector minus 7B vector plus 5C vector is equal to 0 vector. All these points are collinear. So the 3 points. So the points are collinear they have given. So take this relation and here minus 7b vector you just split as minus 2b vector minus 5b vector. From the first two terms you take 2 is common. So a vector minus b vector. From these two terms you take 5 is common. So c vector minus b vector. So a vector is what? It's a position vector. So I will take position vector of the point A. So it is denoted as OA vector. B vector as minus OB vector. And C vector as OC vector. Okay. So using position vector as written. Position vector of the second point minus position vector of the first point. Which is the second point A. Which is the first point B. So it is BA vector. The same way C is the second point. And B is the first point. So it is BC vector. So this BA vector can be written as minus AB vector. So I have changed the initial and the terminal point, so the direction will be changing. So therefore we have to write minus. So BA vector is equal to minus AB vector. This minus AB vector, when you take it to the next side, it is plus 2AB vector. So 5BC vector is equal to 2AB vector you are getting. BC vector is equal to, in the 5 you just bring it down. So 2 by 5 into AB vector. Here one vector is a scalar multiple of other vector. What is the scalar is multiplied here? 2 by 5. It's a number. So it's a scalar multiple of other vector. See the points B, C, here A, B. So from these two vectors, which point is common? B is common. So if you have the common point means the 3 points are collinear. So we have proved the 3 points A, B, C are collinear. Thank you students.